Saxon's Trig, Lesson 34, is about summation notation, linear regression, and decomposing functions. Begins on page 242. The first part, summation notation, is just actually a lot of fun to do, but the symbol that will indicate that you're supposed to do summation notation is this very fancy Greek E. It's not really a Greek E, but it looks like our English E, and it's a Greek symbol. So that's what I mean. When you see this, it is indicating to you that you are supposed to do summation notation. Now, as that would kind of imply, summation is the addition of some things. And there's other parts that have to be given to you. Down below, you will encounter a y equals x equals some sort of letter equals something. This is telling you where you are going to begin. So the first number that you're going to add is a 1. And out here, there is a formula, y squared, and so this means that I'm plugging the 1 into this formula, so that's actually 1 squared. And there will be a top number, in this case 4, that tells you how far you go. So you plug in 1 and square it, plug in 2 and square it, plug in 3 and square it, plug in 4 and square it, and now you've gotten to the top number where it's indicating for you to stop. So the summation notation will be the answer to all of this. 1 plus 4 plus 9 plus 16. And that will be 30, and that's the summation notation there. So example 1, same concept. It gives you I equals 2. It tells you to nope, hang on, example 1. I was looking at something else. I equals 1, and it tells you to stop at 5, and the equation is 3. Now, it's not really an equation, so there's nothing for me to plug in. However, it's going to imply, actually, no, don't even think about that. Just ignore what it is implying. You're going to go with this. From 1 up to 5 means that I'm adding, there's nothing to plug in, so that's 3 plus, for 2 plugging in, 3, for 3 plugging in, for 4 plugging in, and for 5 plugging in. And then the addition, 15. And that is what you'll need there if you have no equation. Now let's go back to one with an equation, example 2. Summation notation up to 4, equation is 2x, and we're beginning with x equals 1. So we're going to have 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. Reach the top number now, I can stop. 2, 4, 6, 8, 21, if I've counted that correctly. Oh, wait a minute. No, it says 20. Let me redo that. 8, 10, 11, 12, 13, 14, 15, 16, 17. Oh, 20. Yep, I just miscounted. There we go. 20 is our answer. Example 3. Summation notation. J is 0 is our start. And at 3. Now our equation is a little more complicated. 2 to the j is the numerator, and j plus 1 is the denominator. We're going to plug in 0, so 2 to the 0, 0 plus 1, plus 2 to the first over 1 plus 1, plus 2 to the third over 3 plus 1. We've reached the top number, so this is all we need to simplify. 2 to the 0 is 1. 0 plus 1 is 1. 2 over 2. 2 times 2 is 4 times 2 is 8. That's 2 cubed. 3 plus 1 is 4. Do some simplification there. 1 plus 1 plus 2. Well, that's easy addition. Hopefully I won't make a mistake there. Oh, did I? Oh, I've done a mistake somewhere. Hang on, I'm not matching the answers. 0, 1. Oh my goodness gracious, I skipped 2. Let's add that here to the end. 2 to the 2 over 2 plus 1. We have another answer to add in here. Plus 4 over 3. Okay, 4 thirds also needs to add in here. Yikes. 4 plus 4 thirds needs a common denominator of 3. That changes this to 12. 12 plus 4, 16 thirds. Now do we match? Much better. Easy addition, but I forgot the fraction. Okay, now let's see if we can do example 4 without any error. We've got our, oh goodness gracious, I can't even do the symbol. Summation notation, stopping at 6, y equals 4, so starting at 4, and the equation 1 over y. Let me move that back over. Okay, so we have 1 over 4 to start, plus 1 over 5, plus 1 over 6, and that all needs a common denominator. So let's see. I'm mentally splitting this 6 into 2 and 3. Actually, no, because this one will be 2 and 2. So 4 times 5, 20 times 3, 60. 60 should be our common denominator. I don't think I've missed one that's lower. So 6 goes into 60. This changes the numerator to 10. 5 goes into 60. So that's going to change the top to 12. And 4 goes into 60 15 times. Oh, they didn't show me. Okay, hopefully I'm on the right track. If you've spotted an error, I'll find it eventually here. 5, 6, 7, 37 over 60. Oh, nope, that is the answer that they had. I didn't have an error in all of my calculations. Part B is about linear regression. And I've gone ahead and jotted down a chart to get us a little bit further so you're not waiting on me to do that entire chart. From example 5, it says the data points from an experiment involving carbon being on my X line and salt being on the Y line are given here. Now they gave us a chart with a series of numbers. And then like I said, I went ahead and started this graph. Now, to be precise, if you were doing it on graph paper, these are a little tighter than these. They should be all spaced about the same. It just didn't happen that way when I did this. So bear with that slight discrepancy here. So in the first set of data points, for carbon, it gave a number of 48. So I need to figure out how much is each section. So 40, 50, 60, that doesn't work to be tens. 40, 50, 60, 70, 80. So each of these is representing 20. So 48, if this is a gap of 20, 48 is going to be pretty close to here because it's been broken into 4 sections. Yes, that would be right. Yes, 20, 4 seconds. Okay, goodness gracious. So I need to be close to about the 4th, but not fully all the way over to the 4th. So we're going to estimate here just a bit. Now, its matching number was salt in grams at 0.8. Now, how far are each of these? 1, 2, 3, 4. That's easy. They're all in ones. So 0.8 is almost up to the 1, but not fully up to the 1 where I put my dot. Now, if you're following in their book, they have a dot with a circle, and I'll explain their circle in a minute. The next number is 70. So that's halfway here. And it matches with 2.5. So that's going to be halfway between the 2 and the 3. The next one is 90. So that's halfway. And it matches with 5.4. 5.4. So halfway between the 5 and the 6. Next one, 108. 100, so that's really tight here, matching with 7.8. So not to the 8, but getting close. The next one, 130, halfway. 6.3, just slightly above the 6, okay. 132, so just a little past that last dot. At 9.4, so a little above that line. That might be a little high. And then finally 158, almost at the 60, and 8.4, just barely above the 8. I need to be a little further back, I think. Somewhere around in here. Okay, so now that we have graphed these dots, they put circles around them to try to say you are looking for a line that is as close to the majority of the dots as you can possibly get. However, if I did here and hit the bulk of these, These are kind of left alone way off. We don't want that either. The line that I want needs to be hitting as close to as many dots as possible without isolating any of them. So if I draw it kind of in between, I'm not hitting a great deal, but I'm fairly close, and that's why they put those circles, to try to give you a feel for where the range of area around them is that you want to be hitting as much as possible. And you'll see that in the line that they drew, they're a little closer to these two than I did, but this is, again, you're approximating where it needs to be. So the data points from the experiment involving carbon and salt are given here. The data are graphed in the figure on the left. In the figure on the right, we estimated the position of the line indicated by these data points. Write the equation of the line which will give salt as a function of carbon. So they're wanting a y equals mx plus b equation for this line that we've that we've estimated, except for the precision of this problem that deals with carbon and salt. It is going to be salt, the y one, equals m, we don't know that slope yet, the x is the carbon, and then we don't know the b yet. Now, when the book provides the line for you in this lesson, we are going to have, as a class, more answers that are close to similar. When we get to you picking where that line goes, and that is an upcoming lesson, our answers will be much further off because our lines are never going to be drawn the same. You're not going to eyeball as close to these exactly the way I did. And like I said, the book has them closer to these two than I eyeballed it. So you're going to have some discrepancies. But for right now, we're going to use the line, and we're going to pick two of the dots that look the closest to the line, these two nearly touching it, and in the book are touching it, these two, and use those to find the slope. Now remember that your slope formula is y2 minus y1 over x2 minus x1. So we're going to take our y values for these two dots, and I'm going to use not the guess from my graph, but the actual precision from the list in the book. So this bottom one here, let's just go ahead and label 48, 0.8, and the other one is 2.5, nope, that's backwards, 70, goodness, 70, 2.5. Okay, so now the y's that we're subtracting, 2.5 and 0.8, 1.7, do they have that here? Oh, they estimated even further in theirs. Okay, I'm gonna go with saying that this is like 0.7, and then the difference, I mean 1.7, I meant 1.7. All right, so I did 2.5 minus this one, so I need to make sure I go in the same order. 70 minus 48, 22. Over 22. And then I don't want a decimal within a fraction, so I definitely want to divide that out into a decimal. Now I'm going to hope that if I did that on a calculator, I would get fairly close to their 0.083 for the m. Hopefully it's somewhere in that ballpark. And then once we, but this is what they got when they did their numbers. Now, I need to get the B. So we are going to fill in what we know so far. And I'm going to leave the S and the C blank for a second. So something equals my 0.083 for the M, something or other plus B. Now, I need to just choose whichever one of these points I want to use. These numbers are bigger, so I'm probably going to go with these. So 0.8 is the salt amount, and 48 is the carbon amount that we're filling in. Now again, calculator, multiply these two together, subtract that answer from 0.8, and I would anticipate getting a negative. And if I use the book's numbers, it tells me that should be negative 3.32. Now that we have the B, we're going to put the whole thing back together in S and C, staying the letters, and M and B being filled in as the numbers. So salt equals 0. I'll put that 0 back in there, 0.83 carbon minus 3.32, and there's the equation for that given line. That's the only example that they do of this, because they feel like you already know how to take some dots and get the equation of the line. They were more interested in explaining why they put the line where they put it. Then they move on to part C, which is decomposing functions. Decomposing kind of sounds like your decomposition. Things are rotting away. They're being worked backwards. And so in example 6, page 245, it says we have, or find two functions f and g. So we are responsible for finding f of x equals something and g of x equals something. And they give us that f of g is the equation square root of x squared plus 1. So I know in this format, I have picked up whatever g's equation was and I have plugged it into f's. So what over here does it look like was plugged into something else? This concept looks like it's been plugged into a root. So I'm going to make the assumption that g is x squared plus 1 and that f is the square root of x. So now I mentally check that. If I pick up this and I plug it in where x was, do I get this? Yes. And so I have decomposed with my best guess. They show you another answer, which is also possible. Okay, so I will show you what they have. They say you could also have f of x is x plus 1 and g of x is x squared. So if you picked up x squared and plugged it in where x was, that would give you x squared plus 1 in a square root. Either one of those are a decomposition. Are you supposed to know which one? No. Are they both valid answers? Yes. Would I expect you to see this one first? Yes, I would. If you see this one first, great. Either answer is acceptable. Both are even better. All right, let's move to example 7. Find the f. So we want to know f of x equals, I guess I could box those, and that was two different answers. All right, so they want to find f of x, and they have provided that g of x is x squared plus 1, and they tell us that f of g of x is, oh, I didn't put the of x there, did I? Lost the problem. Oh, 1 over x squared plus 1. So if I know that this equation is, this means I don't have more choices. I'm much more locked if they give me one of the equations. So x squared plus 1 is being plugged into f's equation, which was a 1 over top of something. So it is 1 over x. Now mentally check that. If I take x squared plus 1 and put it in here, does it give me 1 over x squared plus 1? Yes, it does. So this is the equation for f of x. So that is much easier where, again, they give me one of the equations. I don't tend to have other options.